Okay, so this is the 2024 Ordinary Level Maths Paper 1 Leaving Cert, question 1. So we have a farmer and he buys or she buys a new machine for 30,000 euros. It depreciates, decreases in value by 20% each year. Find the value of the machine after 1 year. Okay, so what we got to do here is reduce it by 20%. So we're going to take 30,000. We're going to multiply it by 1.0, if you like, minus the 20%, minus 0.2. So we're going to multiply by 0.8. When you do that, you get 24,000 euros. Or if you want to use the formula, there is a formula in the tables. F is equal to P1 minus I to the power of T. F is the final value, P is the principal, I is the interest rate as a decimal, and T is the time. So the principal here is 30,000. It's 1 minus 20% as a decimal, so 1 minus 0.2, this is where the 0.8 comes from. And we raise that to the power of 1. So you can see that here we have the 0.8, here we have the 30,000, and you'll get your 24,000 euros there. Okay, so that's the first one done. Let's have a look at the second one. Hence or otherwise, find the value of the machine after 2 years. So here you can do the same again. You can reduce the 24,000 by another 20%, or if we use the formula, F is equal to P1 minus I to the power of T. We can start with our 30,000, 1 minus 0.2, and this time 2 years. So if you do that on your calculator, you get 19,200 euros. Or as I say, you can take the 24,000 from part 1 and multiply that again by 0.8, and you'll still get 19,200 euros. Okay, let's have a look at the next one. Part B, a farmer bought some livestock for 4,716 euros including VAT. The cost of the livestock was 4,500 excluding VAT. Calculate the percentage of VAT. So really what you've got to do here is take the 4,716, you've got to subtract the 4,500. That will give you the amount of VAT that he actually paid. In this case it's 216 euros. You put that, you want the percentage VAT. This is the VAT here. We want the percentage VAT. So the percentage VAT then is just going to be 216 divided by the original amount, which was 4,500. You've got to multiply that by 100 and you'll get 4.8%. Okay, that's part B done. Let's have a look at part C. The farmer also bought land. 1 year later its value had decreased by 12.5% and was now 52,875 euros. Find the value of the land when the farmer bought it. So we want the value of the land when the farmer bought it, so we're going to put that on the right hand side, 52,875 euros. That's equivalent to what percentage? Well, that's going to be equivalent to 112.5%. It's more than 100%, it's 112.5%, because we're taking the original cost, which was 100%, and we're adding 12.5% to it. What we really need to do is go down to 1% first and then find out what it is when it was 100%. So what we're going to do is we're going to go down to 1% by dividing 112.5 by 112.5 divided by itself. That'll give you 1, and then to bring it up to 100 we're going to multiply by 100. To bring 1 up to 100, multiply 1 by 100. You do exactly the same on the right hand side. So first of all we're going to divide by 112.5 and then we're going to multiply our answer by 100. So if you do that you get 52875 divided by 112.5, and then down here 52875 divided by 112.5 multiplied by 100. When you do that, you get the original cost, which was 47,000 euros. And that's it for question 1. Okay, so let's have a look at question 2. In this question, I squared is equal to minus 1. The complex numbers Z1, Z2, Z3 are shown on the Argand diagram below. One of these numbers is on the imaginary axis. So we have our diagram here. Here we have Z1, Z2 and Z3. Using the Argand diagram, write down the values of Z1, Z2 and Z3 in the form A plus BI, where A and B are elements of Z. Okay, so Z1 is out here, so that's going to be 4 plus 3i. Let's write that in, 4 plus 3i. Z2 is here, and that's going to be 0 plus 2i. And Z3 then is out here, that's minus 2 minus 1i. That's it for part 1. Let's have a look at part 2. Write down the value of the modulus of Z2. So the modulus of Z2 is going to be the modulus of 0 plus 2i. What that involves then is taking the square root of a squared plus b squared. So our a is 0, we've got to square it. Our b is 2, which we've got to square. So 0 squared is 0, 2 squared is 4, the square root of 4 is just 2. So the modulus of Z2 is just 2. Okay, let's look at the next one. So in this case we have v is 15 over 1 plus 2i, write v in the form a plus bi. So this is taking 15 and dividing it by a complex number, 1 plus 2i. So what you need to do here is multiply by the denominator's conjugate. The conjugate over itself. The conjugate is 1 minus 2i. So you divide that by 1 minus 2i as well. So 1 minus 2i divided by 1 minus 2i is just 1. So all we're really doing here is just taking 1 and multiplying it by this fraction. So if you multiply any fraction or anything by 1, you're not going to change it. So we haven't changed the fraction here, but it will help us get rid of that fraction, if you like, and rewrite it in the form a plus bi. So if we multiply the top by the top, the bottom by the bottom. So 15 times 1 is 15. 15 times minus 2 is minus 30. And then we're going to divide that by 1 times 1 is 1. 1 times minus 2i, minus 2i. Plus 2i times 1 is plus 2i. And then plus 2i times minus 2i. Well, plus times minus is minus. 2 times 2, 4. I times I squared. So let's just simplify this. We've got a 15 minus 30i. Got to divide that by 1 minus 2i plus 2i will give us 0. Now remember I squared is minus 1, so minus 1 times minus 4 is plus 4. So that'll leave us with 15 minus 30i divided by 5. I'll just come over here. You must divide the 5 into both of these because the two terms on top are separated by a plus or a minus. So 5 into 15, 3, 5 into 30, 6i. And that's it for part B, 3 minus 6i. Let's have a look at part C. The complex number w is 1 plus 2i, and it's shown in the diagram below, drawn to scale. Let's see, the three complex numbers labelled a, b and c are also shown on the Argand diagram. One of these is w with a bar over the top, the complex conjugate of w. So I guess they're asking us which one is it. So our complex number is w, it's here. The conjugate of that is going to be this one here, it's going to be c. Because if you take a complex number, if you take any complex number, a plus bi, the conjugate of a plus bi is a minus bi. So our answer was C, and the complex number itself was, what was it, 1 plus 2i. So the complex conjugate of 1 plus 2i is 1 minus 2i, which is, if you like, the image of w under axial symmetry. Under axial symmetry in the x axis. So when you have a complex number, any complex number, its conjugate is going to be that complex number reflected in the x-axis, or in this case I should really say the real axis. So when you have any complex number like w here, its complex conjugate is going to be the image of that complex number under axial symmetry in the real axis. So I should really say, rather than the x-axis here, I'm going to say the real axis. Okay, and that's it for question 2. Okay, let's have a look at question 3. A toy shop sells two different sets of the same building blocks. Set A and set B is shown in the table below. So set A, number of blocks 60, cost 12 euros. Set B, 150 blocks, cost 28 euros. Which set of building blocks works out cheaper per block? Use calculations to support your answer. So let's have a look at that. So we take set A. Well, set A sells 60 blocks, which is equivalent to 12 euros. So 60 blocks for 12 euros. So that means one block is going to be equal to 12 over 60 euros, which is 0.20 euros. Let's have a look at set B. Set B sells 150 blocks, which is equivalent to 28 euros. So one block is going to be equal to 28 divided by 150. And if we do that, we get 0.186 euros. So the question was, which set of building blocks works out cheaper per block? So set B is going to be cheaper because it's 0.186. Set A is 0.2. Okay, so let's move on to part B. Solve the following equation in x, which is real. So give your answer correct to two decimal places. So we've got 3x squared minus 5x plus 1 is equal to 0. Because they say correct to two decimal places, this should kind of give you a clue that you're going to have to use the quadratic formula. So in this case, A is equal to 3, B is equal to minus 5, and C is equal to 1. So x is equal to minus b, so it's minus minus 5, which is plus 5, plus or minus the square root of b squared, put it in brackets, minus 5 squared, minus 4ac, minus 4a is 3, c is 1, and then underneath in the bottom part it's twice a, so it's twice 3. These are your answers here. So we got 5 plus or minus the square root of minus 5 squared is plus 25. It's a common mistake here to write down minus because you see a minus here, but remember you're squaring the minus as well. So minus times minus is plus, so that's 25. Here we've got a minus times a plus, so that's going to be minus 3 4 is 12. So we have, let's see, 5 plus or minus the square root of 25 minus 12, that's 13. So these are our two answers here. So our answers are going to be then x is equal to, and x is equal to, you've got to do 5 plus the square root of 13 over 6, and you've got to do 5 minus the square root of 13 over 6, and you've got to round them to two decimal places. So in the first case, when you do plus, it's 1.43. When you do the minus 1, it's 0.23. There are two answers there. Okay, let's have a look at part C. Use algebra to solve these simultaneous equations. And they even give you a hint as well. Okay, so what you normally do in this case, when you've got a linear, this is a linear equation, this is a non-linear equation. What you've got to do there is take the linear one and rewrite it so that y is equal to everything else, or x is equal to everything else. So I'm going to take 2x plus y is equal to 5. I'm going to rearrange it so that y is equal to 5 minus 2x. So now I have y in terms of x. So what I can do is I can take the right hand side of this, substitute it into the second equation. The second equation is x squared plus y squared. Now I have y already as 5 minus 2x. That's my y from the first thing I've done, which I've got a square, and that's equal to 25. So now I've got an equation with only x's in it, so I can work out what x is. So let's work through that. We've got x squared plus, you've got to multiply this out. It's 5, remember this is 5 minus 2x times 5 minus 2x. So you've got to multiply this by this, you've got to multiply this by this one by this one, and this one by this one here. So 5 squared is 25, and then 5 times minus 2x is minus 10x. Minus 2x times 5 is minus 10x. And then minus 2x times minus 2x is plus 4x squared. That's equal to 25. Now this is a quadratic trinomial, I think, or at least it's going to be a quadratic binomial. So what you've got to do is bring everything over to one side. So add the x squareds. First of all, we've got an x squared and a 4x squared. That's 5x squared. We've got a minus 10x, that's minus 20x. We have a plus 25 here, and we've got a 25 on the other side of the equation. So if I was to take the 25 on the right hand side and bring it over to the left hand side, subtract 25 from both sides, the 25s will disappear, we'll get 0. So that's what I'm left with when I simplify all of this. Okay, so we have a quadratic binomial, if you like. So what you're going to do here is you have to factorize. So what you're going to do is take out the highest common factor. So we have a 5 and a 20, so the highest common factor is 5. We have an x squared and an x, so the highest common factor is x. Now what would I multiply 5x by to give me 5x squared? Well, just x. What would I multiply 5x by to give me a minus? Well, minus. Plus times minus is minus. 5 will have to be multiplied by 4 to give me 20. And the x times 1, so that's 8. Okay, so now I have a 5x times an x minus 4, and my answer is 0. When you have two terms multiplied by each other and your answer is 0, that means one of those two must be 0. So in other words, if I have an a and I multiply it by a b and my answer is 0, a must be 0 or b must be 0. One of those must be 0. Otherwise we won't get 0 as an answer. So in other words, 5x must be equal to 0 or x minus 4 must be equal to 0. If 5x is equal to 0, divide by 5 and divide the right hand side by 5. Divide the left hand side by 5, you get 1x. Divide the right hand side by 5, you'll get 0. Or we've got x minus 4 is equal to 0. So add 4 to the left hand side, you'll just get x. Add 4 to the right hand side, you'll get 4. Now this question asks us to solve the following simultaneous equations. So we have solved it, we found the two values of x. And that's really it for this question. Okay, so this is question 4. Solve the following equation in x, which is real. So let's do that then. We've got 4 times 2x minus 5 minus 1 is equal to 3x plus 7. First thing you need to do here is multiply out the brackets. So it's 2 4s 8x minus 4 5s 20 minus 1 is equal to 3x plus 7. Bring the x's over to the left hand side. So if you subtract 3x from both sides, you'll get 5x on the left hand side. Now we also have this minus 20 and minus 1, so that's minus 21. I'm going to bring that over to the other side. So that becomes plus 21, and then just add that to the 7, you get plus 28. So what I need to do now is just divide by 5, because the 5 is multiplied by the x, so we do the opposite. So we end up dividing the right hand side by 5 and we get 28 over 5. Okay, so that's part A finished. Let's have a look at part B. Liam, Joan and Martha split a bill in the following ratio. So the ratio is 4 is to 3 is to 5. So this is Liam, Joan and Martha. Liam and Joan pay €154 in total between them, so Liam and Joan, so that's these two here, they pay €154. Martha pays the rest of the bill. Work out how much Martha has paid. Okay, so what we need to do here first with ratios, you just add up these three numbers here. So it's 5, 6, 7, 8, 9, 10, 11, 12. So you add them up, you get 12. So really, Liam and Joan have paid 4 plus 3, which is 7. out of the 12 parts of the bill. So you add these two up here. Let's just work that out. We know that 7/12 is equivalent to 154 euros. So we want to know what 5/5 is. So there are a number of ways of doing this, but the way I would usually do it is see what 1/12 is. So in other words, we've gone from 7/12 down to 1/12. So what did we do to do that? We divided the left hand side by 7. So divide the right hand side by 7. Now we want to know what 5/12, this 5/12 is. So in order to work that out, all we've got to do is multiply by 5. So we're going up to 5/12. So we're going to multiply this 154 over 7, multiply that by 5. When you do that, you get 110 euros. So it says work out how much Martha has paid. So this is equal to Martha's bill, if you like. Okay, so that's it for part B. Let's have a look at part C. Write 128 in the form 2 to the power of k. So that's fairly straightforward. You can just do that on your calculator. You just take 2, multiply by 2, multiply by 2, multiply by 2, keep pressing equals until you get 128. And you'll find you have to multiply 2 by itself 7 times. So it's 2 to the power of 7. And that's it. Hence or otherwise. So usually when they say hence or otherwise, use the hence part. In other words, they've already told you how to do something that's going to be useful. So use that. So we got 2 to the power of 4x plus 1 is equal to 128. Now they've already told us to, if you like, use what we've done already. So what was that? We've turned 128 into 2 to the power of 7. So when you've got 2 to the power of something equals 2 to the power of something, the somethings are going to be equal. So in other words, the 4x plus 1 is equal to 7. Bring the 1 over to the other side. Subtract 1 from both sides. In other words, we'll get 6 on this side. And then the 4 is multiplied by the x. So what we're going to do is divide by 4. So you'll end up with 6 over 4. Or if we simplify that, you'll get 3 over 2. And I think that's all we had to do. Hence or otherwise solve the following equation. And that's it for this question. Okay, so this is question 5. Find the value of the following expression when x is equal to 2. Give your answer in the form a over b, where a over b are natural numbers. 3x plus 5 over 10 minus 1 over x plus 3. Okay, so let's just substitute in 2. So it's going to be 3 times 2 plus 5 over 10. 1 over 2 plus 3. Okay, so let's just do that. We've got 3, 2, 6. 6 plus 5, 11 over 10. And here we've got 1 over 3 plus 2, 5. So now we've just got to add these two fractions. So 10, 5, our common denominator there, our lowest common multiple is going to be 10. So this is going to be 11 over 10. And then minus, what do we do to that 5 to turn it into 10? We multiply by 2. So we got to multiply the top by 2 as well. So 2 ones, 2. So our answer then is going to be 11 minus 2, which is just 9 over 10. So give your answer in the form a over b, where a and b are natural numbers. So that's correct. Okay, next part then. The function f is defined as f of x is equal to 5x squared minus 20x plus 2. X is real. Use calculus to find the coordinates of the local minimum point of x. So to find the local minimum, what you've got to do is differentiate, which will give us a function for the slope of any tangent on the curve. This is a quadratic, so it's going to look like this. So what you do is you take the 2, bring it down, multiply by the 5, that'll give you 10, reduce the power by 1, so it's x to the power of 1. Here we have an x to the power of 1, bring that down, multiply it by 20, you get 20, reduce the power by 1, so you end up with x to the power of 0, which is 1. So we just end up 20 times 1, which is 1. So this function here, 10x minus 20, will give us the slope of any tangent on the curve. So what we want to do is find the local minimum point. So the local minimum point is going to be here. The tangent at that point will look like this, which will have a slope of 0. So we want the slope 10x minus 20 to be 0. So all we got to do is just solve that for x, find what that x value is. So just add 20 to both sides, get rid of the 20, divide by 10, you get x is equal to, you get x is equal to 2. So that tells us that this point here has an x value of 2, and it says find a coordinate, so we got to find the y value. So the y value we can find by putting it into the original function. The original function is y is equal to 5x squared, or x is 2, minus 20 times 2 plus 2. So 2 2's are 4, you must do the power first. 2 2's are 4, and then 4 5's 20. Minus 20 times 2, 40, and then plus 2. That'll give you a y value of minus 18. So our y value here is minus 18. So the point at the minimum is going to be 2. So my answer here, if you like, the minimum point is going to be 2 minus 18. And that's it for part B. Let's have a look at part C. The graph of the linear function g of x is shown. So what do we have to do with that then? Use the graph to find the rate of change of g of x. That is, find g prime x. Give your answer in the form a over b. So really, as I said earlier in the previous part of this question, when you differentiate a function, you get slope. So in other words, when you get slope, you get the derivative of the function. So what I'm going to do is find the slope of this line here. So in order to find the slope of a straight line, it's really just rise over run. So let's just find a triangle. I'm going to use this one here. I'm going to come down, and I go down further. Actually, I'll go down to this one because it finishes at a whole number, and I'm going to come across like this. So you can see here that on the y part of this triangle, it is 1, 2, 3, 4 units, and then on the x part it's 6 units. So the slope of this line is rise over run, which is 4 over 6. So the slope, which is going to be equal to g prime x as well, they're the same thing if you like, is 4 over 6, or 2 over 3. And that's really it for this question. Okay, so this is question 6. The graph of the function k of x is shown on the coordinate diagram below. X is between 0 and 5, and x is real. Use the graph to answer parts A, 1 and 2. Okay, estimate the value of k of x when x is 2.5. Show your work on the graph. So x is 2.5, which is here. So what you'll be required to do in the exam is get your ruler and come up along here and then along here. I'm doing this freehand, so it's a little bit shaky. You guys should use a ruler. So I'm getting, let's say, 5.9. So I'm going to say k of 2.5 is approximately equal to 5.9. Now I'd imagine in the marking scheme there's going to be a tolerance around that, so don't worry if you didn't get that exactly. Now let's see, estimate the range of values of x for which k of x is less than 7. Show your work on the graph. So we want k of x to be less than 7. So k of x is y. So in this case we want to start at 7 here. The y is equal to 7. Come over here and then come straight down. Again, use a ruler. So I'm getting, let's say, 1.8. What we would say here is that k of x has to be less than y has to be less than 7. What x values would you get, in other words? So we're looking at this part of the graph here, which is this part of the graph, this part of the curve. So we're talking about these x values out here. So we're really talking about x values greater than 1.8. So we want x to be greater than or equal to, I think it is 1.8. Yeah, it's equal to. So we want x to be greater than or equal to 1.8. Now there may be a second answer to this. If they're just talking about the graph itself, they may want us just to stop at 5. In which case you would write your answer like this: x is greater than or equal to 1.8, less than or equal to 5. Not sure about this, but strictly speaking it's this answer here. Okay, so that's part 2. Let's have a look at part B. Liam uses the trapezoidal rule to estimate the area under the graph of k of x between 0 and 5. He takes the following measurements from the graph on the previous page. Using the values of k of x in the table above, show that the trapezoidal rule will give an estimate of 32.1 units for this area. So the trapezoidal rule is in your tables. It is the area is going to be approximately equal to, it's only an estimate for the area, it's going to be h over 2. The h is these values here, the difference between 0 and 1, the difference between 1 and 2, the difference between 2 and 3, in other words. So we're going up in ones. So the h is going to be 1. You divide that by 2, and you divide by the first value, which is 12, plus the last value, which is 2.8, and then it's twice all the rest of them added. So it's twice 9 plus 6.8 plus 5.1 plus 3.8. That's really it. When you do all of that, it's just calculator work. Do what's in the brackets first, in the inner brackets, multiply by 2, add the 2.8, add the 12, and get half of your answer. You should get 32.1. 32.1. And the units there are, let's see, trapezoid. It doesn't say anything about units, just units. Units squared. Okay, so that's it. That's really part B1. Let's have a look at part B2. The actual area under k of x between 0 and 5 is 31.8. So that's the accurate area if you were to do it accurately. Liam estimated the area was 32.1 using the trapezoidal rule. Work out the percentage error. So the first thing you do is work out the error. So you take the 32.1 and you subtract 31.8. And that gives you the difference between the accurate value and the approximate value, which is 0.3. The percentage error then is just given by the error, which is 0.3, divided by the accurate value, which is 31.8, and then we want it as a percentage, so you multiply by 100. When you do that, you get 0.94%. That's it for this question. Okay, so this is question 7, the first of the longer questions. And let's see, during an experiment, the number of bacteria in a dish can be modeled by the function p of t, t cubed minus 6t squared plus 6t plus 20, where p of t is the number of bacteria in thousands, and t is the time in hours since the start of the experiment. T is between 0 and 5, and t is real. Complete the table below to show the values of p of t for the given values of t. So really all you've got to do here is put in the t values. So for example, if we do the first one, p of 0 is 0 cubed minus 6 times 0 squared plus 6 times 0 plus 20. When you work that out, you'll find that you get 20. You then do p of 1, so it's the same thing again, 1 cubed minus 6 times 1 squared plus 6 times 1 plus 20. Again, just remember to do the powers first, then the multiplication, as in this case here. So you got to do the 1 squared first and then multiply by 6. So you should get 21, and then if you put 3 in, you should get 11. If you put 5 in, you should get 25. That's it. Let's have a look at part 2. We have to draw this, I presume. Yeah, so you just got to put in these values here. So we've got to put in 0, 20. So 0 on the x-axis, 20 on the y-axis is here. We've then got to do, let's see, 1, 21. So 1 is here, 21 is approximately here, just slightly higher. And then 2 is 16. So 2 is here, and 3 is 11. So 3 up as far as 11, which is roughly there. And then 4 is 12, or just slightly higher. And then 5 finally is 25. So 5 is halfway here, so it's about there. And then you just join those up. So it's going up slightly, and down, come around and up. Okay, so that's it for part 2. So for part 3, find p prime t, the derivative of p of t. Remember that p of t is t cubed minus 6t squared plus 6t plus 20. So p prime t then, the first derivative, is going to be, take the 3, bring it down, multiply by t, reduce the power by 1. Bring the 2 down, multiply by 6, you get 12, reduce the power by 1. Bring the 1, there's a 1 there, bring that down, multiply by 6, reduce the power by 1, you'll get t to the power of 0, which is 1. So you just get a 1 there if you like. Differentiate a constant, you just get 0. So it's 3t squared minus 12t plus 6. That's it for part 1. It then says in part 2, or part 4 I should say, part 3 and 4, find the value of p prime 2. So we have p prime t, we now want to just stick in a 2. So we go 3 times 2 squared minus 12 times 2 plus 6. So that'll give us, again, remember, do the power first. So it's 2 squared first, which is 4. Multiply the 4 by the 3, you get 12. Minus 2 12s, 24, plus 6. That'll give us finally an answer of minus 6. And if you want to put in units here, it's the rate of change, so it's going to be the number of bacteria per hour. So it's reducing by 6 bacteria every hour, after 2 hours, or at 2 hours if you like. Okay, so let's look at the next part. P prime 4 is equal to 6. Explain what this means in terms of the number of bacteria. So we got to explain this. Okay, so we have P prime 4 is equal to 6. This means that the number of bacteria in the dish is increasing. Because 6 is positive, it's increasing by, now 6 is actually 6,000, because remember these numbers are in thousand, by 6,000 per hour at 4 hours. So in other words, when the time is 4 hours, the bacteria in the dish are increasing. The number of bacteria are increasing by 6,000 every hour. The rate of increase is 6,000 every hour. So let's look at the next part, part B. The number of bacteria in a different experiment can be modeled by the function k of t is equal to 3,000 by 2.72 to the power of 0.5 t, where k of t is the number of bacteria and t is the time in hours since the start of the experiment, where t is between 0 and 8, t is real. There are 3,000 bacteria at the beginning of the experiment. Use kt to find the number of bacteria after 1 hour, and after 2 hours give your answer correct to the nearest whole number. Right, so we're just going to do, in other words, k of 1, and we're going to do k of 2. That's all we've got to do. So we've got to just stick 1 into the formula and then 2. So it is 3,000 times 2.72 to the power of 0.5 times 1. So you'd multiply 0.5 times 1, raise 2.72 to the power of that, which is 0.5, and then multiply your answer by 3,000. You should get 4948. Over here then you do the same thing again, but this time you put in 2. So it's 2.72 to the power of 0.5 multiplied by 2. So 0.5 multiplied by 2 is just 1. So you're just raising 2.72 to the power of 1. And you should get 8160. So after 1 hour there are 4,948 bacteria. After 2 hours there are 8,160 bacteria. This is the number of bacteria here and bacteria here. Okay, so that's part 1. Let's have a look at part 2. After n hours there are at least 35,000 bacteria according to k of t, where n is natural. By continuing the pattern above, or otherwise find the smallest possible value of n. So we've done 1 and 2, so I'm going to do k of 3, which is 3,000 times 2.72 to the power of 0.5 times 3. That will give me, let's see, 1, 3, 4, 5, 7 bacteria. I'm going to do K of 4. Again, it's the same thing, just put in a 4 there and you'll get 22,195 bacteria. Put in 5 and you'll get 36,605 bacteria. So what we want is 35,000. We want at least 35,000. So when we got as far as n is equal to 5, we got 36,605. So our answer here is that n has to be equal to 5. So 5 is the first number where we exceed 35,000. Okay, so that's it for this question. Okay, so let's have a look at number 8. Liam left home at 7 in the morning. He cycled at a constant speed of 20. He cycled at a constant speed for 20 kilometers until he reached a point A. He then changed speed and cycled at a constant speed for a further 12 kilometers until he reached a point B. The graph shows his distance from home along the route cycled until he reached B. Use the graph to estimate the distance Liam had cycled by 8 in the morning. Show your work on the diagram. So we start at 8 and we just go up along here and then across. I'm going to say 13.5 kilometers. So again, there will be a tolerance around this in the marking scheme, so don't worry if you didn't get that exactly. Find his speed in kilometers per hour when he was traveling from A to B. So from A to B, the speed is going to be the slope of this line here. It's going to be the slope of this line. So what we got to do is have a look at drawing a triangle down here. From A to B, that's a right angle triangle. The slope of that line will give us the speed, the kilometers per hour. So from here to here, up along the y part of this triangle, the rise, if you like, is going to be from 20 up to 32, which is 12 units, or 12 kilometers if you like. And then along the x part, along the run part of this triangle, we're going from 8:30 to 9, that's 30 minutes or 0.5 of an hour. So the slope of that line is 12 over 0.5. So the slope is equal to 12 divided by 0.5. That'll give us 24 kilometers per hour. So that's his speed along that part from A to B. Part 3. Use the following information to complete the graph on the diagram above to show the rest of Liam's journey. So Liam stopped at B for 30 minutes. So let's draw that in. So he stopped at B for 30 minutes, so that's from 9 to 9:30. So we're going to draw a straight line across here. And then the second part is Liam then cycled 32 kilometers back home at a constant speed. This took him 1 hour. So it's going to take 1 hour, so it's from 9:30 to 10:30. So you got to just draw a straight line down here. Again, use a ruler, don't do this freehand like I'm doing. It's not quite a straight line, but it must be a straight line in the exam anyway. So that's really it for that part of the question. So let's have a look at part B. Ellie takes up running. In the first week she runs 6 kilometers. Each week after this she runs 1.5 kilometers more than the previous week. Complete the table to show the distance Ellie runs each week for the first 6 weeks. So all you got to do here really is just add 1.5 to each of the values. So we're going from 7.5, add 1.5, you'll get 9, add 1.5, you'll get 10.5, add 1.5, you'll get 12, and then add 1.5, you will get 13.5. So that's part 1. If Ellie continues with this pattern, find the distance she would run in week 100. So really this is a linear pattern. What's happening here is we've got 6, 7.5, 9, 10.5 and so on. Our common difference here is plus 1.5, plus 1.5, plus 1.5. So in this case our first term is 6 and our common difference is 1.5. So I'm just going to make a formula here to work out any particular Tn. So you know from your tables again that Tn is equal to A plus n minus 1 times d. So our A is 6, we've got n minus 1 and our d is 1.5. Just simplify that, you've got 6 plus 1.5 n minus 1.5. That'll finally give us, let's see, 6 minus 1.5 is 4.5 plus 1.5 n. So this is a formula we can use to work out any particular Tn. We want week 100, so what we want is T100. So that's 4.5 plus 1.5 times 100. So 1.5 times 100 is 150, then add 4.5, you've got 154.5 kilometers. And that's it for part 2. Part 3 here, it says explain why Ellie cannot continue this pattern indefinitely. Let's see, there are a few different ways of explaining this. She can only run a limited distance. So anyone can only run a particular distance, and at that stage you're going to run out of energy. Or, no one can run forever. Or let's see, there is a limited distance. That she can run. It's really the same as what I said at the beginning there, but something along those lines should do. Okay, so that's part 3. Let's have a look at part 4. Sn is the total distance in kilometers run by Ellie after n weeks, where n is a natural number. Write Sn in terms of n. So again, from your tables, Sn is equal to n over 2 times 2a plus n minus 1 times d. So we just got to put in the numbers that we want for this particular question. So n is going to be n, 2, twice the first term. The first term was 6, n is just n, and d was 1.5, so we put that in there. So you just simplify that, so you get n over 2, 2 6 is 12, plus 1.5 n minus 1.5 when you take away the brackets. That'll give us n over 2 times 12 minus 1.5 is 10.5 plus 1.5 n. And you could multiply out the brackets again, but let's just leave it at that. Sn is the total distance. Write Sn in terms of n. I've done that. That's enough for that one, I think. Let's have a look at number 5. Using your answer to part B4, or otherwise find the total distance run by Ellie in kilometers after 10 weeks. So really we want S10. So we have to go back here again, have a look at our formula. So it's going to be 10 over 2, 10.5 plus 1.5 times 10. And we just got to work that out. So 10 over 2 is 5. We've got 10.5 plus 15 when you multiply 1.5 by 10. So that's 5 times 15 plus 10.5 is 25.5. Multiply that out. 5 times 25.5 is 127.5, and that's kilometers. And that's it for this question. Okay, so let's have a look at the next question. This is question 9. A ticket for the concert in Wales costs €59.50. Using the exchange rate, €1 is equal to 8.85 a pound. Find the cost of the concert ticket in euros. So we have €1 is equal to 0.85 or 85 pence, 80.85 a pound. We need our answer in euros, so I'm going to just switch these around and put euros on the right hand side. So it's 0.85 pounds is equal to €1. Now we want 59.5 pounds, so what I'm going to do is again go to £1 and then go up to 59.5 pounds. Well, on the left hand side what we do is we go from 0.85 to 1. How do you do that? You divide by 0.85. 0.85 divided by 0.85 is 1. Next thing you do is you go from 1 up to 59.5. How do you change 1 to 59.5? You multiply by 59.5. 1 multiplied by 59.5 is 59.5. So you do exactly the same on the right hand side. So we're going to divide by 0.85 and we're going to multiply by 59.50. So it's 1 divided by 0.85, and then you've got to take 1 divided by 0.85 and you've got to multiply, that is 0.85 there. So 0.85 you've got to multiply by 59.5. So when you do that, you should get 70 euros. And that's it for part 1. Let's have a look at part 2. Liam is a member of the Venues Loyalty Club, so he gets a discount of 20% on all tickets. He buys 8 tickets for the concert. Work out the total cost of the 8 tickets in euros. So first of all, the tickets are going to cost 70 euros each. You've got to multiply that by 8. That's 560 euros, and then he gets a 20% discount, so you've got to take 560 euros and you've got to reduce that by 20%. In other words, multiply by 0.8. When you do that, you get 448 euros. That's it for part 2. Okay, so part B then. Liam flies to the concert. He finds the following information. The airplane emits 28,000 grams of carbon per kilometre during the flight. His total flight distance is 394 kilometres. There are 244 passengers on the flight. Work out the amount of carbon emitted during the flight per passenger. Give your answer in kilograms, correct 1 decimal place. So we have grams and kilograms, so we just got to be a little bit careful there. So if we take the 28,000 grams and multiply that by 394, that'll give us the amount of grams of carbon used during this particular flight. So that is 11032,000, and that's grams. So let's just convert that to kilograms. So there are 1,000 grams in a kilogram, so it's 11032 kilograms. And you've got to work out the amount of carbon emitted during the flight per passenger. So there are 244 passengers, so we're going to divide by 244, and that'll give us 45.2 kilograms. And that's it for part B. Let's look at part C. The number of people who will attend a concert, the attendance can change depending on the price of the ticket. For a particular concert, this can be modeled by the function a of x. So we have a of x is equal to 17,600 minus 160x, where a of x is the attendance at the concert and x is the price of the ticket in euro. X is between 0 and 110 euros. X is real. Use the function a of x to answer part C1 and C2. Find the attendance at this concert if the price is 20 euros. So all you've got to do is do a of 20. So that's 17,600 minus 160 times 20. So again, that's just some calculator work. You'll get 14,400. Okay, so that's it for part 1. Part 2, find the price of a ticket if the attendance would be 12,800. Again, we have the attendance, a of x, is equal to 17,600 minus 160x. We're given the attendance now, so we're told the left hand side is 12,800. We've got 17,600 minus 160x. All we've got to do is find the price, find out what x is. So what we've got to do is take 12,800 and subtract 17,600. That'll give us minus 4,800 is equal to minus 160x. Next thing you do is you divide by minus 160. Remember that minus 160 is multiplied by that x. So you got to divide by minus 160, and that'll give you 30 euros. So for an attendance of 12,800, they would need to charge 30 euros per ticket. Okay, let's have a look at D. For a different concert, the total ticket sales in euros can be modelled by 15,000x minus 150x squared. Again, x is the price of a ticket in euro. For this concert, the total ticket sales are 360,000 euros. Use this information to show that x squared minus 100x plus 2,400 is equal to 0. So we know that 15,000x minus 150x squared. So we know that this is the total ticket sales in euros for a different concert. We're told in this particular case for this concert the total ticket sales are 360,000 euros. So that's our equation. We've got to mess around with that until we get this thing here. So let's do that. So what I'm going to do here, I'm assuming that all of these terms will divide by 150, and I can see, I think that they will. Yeah. So if you take 150,000, divide by 150, you'll get 100x. If you take 150, divide by 150, you'll get 1, so that's just x squared. If you take 360,000 and divide it by 150, you'll get 2,400. So that kind of simplifies it, and it gives us the numbers that we need in our question. So all you've got to do is bring everything over to one side. Let's just take the left hand side. So I've just brought the 2,400 over to the left hand side. Now I'm almost there. What I've got is the answer, but with the signs wrong, if you like. So what I've got to do is multiply every term by minus 1. So if I multiply the first one by minus 1, I'll get x squared. Multiply the second one by minus 1, I'll get minus 100x. Multiply the minus 2,400 by minus 1, I'll get plus 2,400. Multiply the 0 by minus 100, I'll get 0. That is it. That's the end of that part of the question. Okay, let's have a look at the next one then. It says solve the equation to find two possible ticket prices for this concert. So we have x squared minus 100x plus 2,400 is equal to 0. So we've got to solve this. Now a couple of ways of doing this. There are quite a few ways of doing it actually, but we can factorize, or we can use the minus b or the quadratic formula. It's up to yourself what way you want to do it. This will in fact factorize, so I'm just going to do it that way. You'll find that x times x will give you x squared, and you'll find 60 times 40 will give you 2,400. We need plus 2,400, so the signs have to be the same. Because the first one is a minus, it's going to be minus minus. So this just means that x minus 60 is equal to 0, or x minus 40 is equal to 0. So finally just add 60 to both sides, x is equal to 60, or add 40 to both sides, x is equal to 40, and these are in euros. Okay, and that's it for this question. Okay, so let's have a look at the last question then, question 10. In 2023, Joseph had a gross annual income of 48,000. He pays net annual income tax of 7,650, annual PRSI of 1,920 euros, and pays 1,407 euros in USC each year. He has no further deductions from his gross income. Work out his net annual income. Okay, so his net income is just going to be equal to his gross income, which is 48,000, minus all the deductions. So his income tax is 7,650, PRSI is 1,920, and his USC is 1,407. So you just got to subtract those three numbers, and you should get 37,023 euros. Okay, that's the first one. Let's have a look at the next one. Hence write his net annual income as a percentage of his gross annual income. Give your answer correct to the nearest percent. So this is just a case of writing one number as a percentage of another number. His net annual income is 37,023 euros. You've got to write that first of all as a fraction of his gross annual income, which was 48,000. And then to convert a fraction to a percentage, you multiply by 100. When you do that, you get 77% to the nearest percent. Okay, so that's part 2 done. Let's have a look at part B. The two income tax rates in Ireland in 2023 are given in the table below. The first 40,000 you have to pay 20%, and then anything over 40,000 you've got to pay 40% tax. Olivia's gross annual income is 34,000 euros, so she's below 40,000, so she's only going to pay 20% in tax. Her tax credits are 3,550 euros. Find her net annual income. So all we've really got to do is find her net tax, which is 20% of 34,000. Because remember, she doesn't reach 40,000, so she's only going to pay 20% in tax. And then to find the net, this is her gross tax. This part here is her gross tax. So to find the net tax, we've got to subtract any tax credits, which is 3,550. So 20% of 34,000 minus 3,550 is 3,250 euros. So this is how much tax she actually has to pay. Now the question says find her net annual income. So her net income then is her gross income, which is 34,000 euros, and then subtract the net tax, which is 3,250 euros. So when you do that, you get 30,750 euros. That's it for part 1. Let's have a look at part 2. Caroline's gross annual income is 50,000. Her annual tax credit is 3,550 euros. Find out how much annual income tax she pays. Okay, so let's look at her net tax. First of all, it's going to be 20% of the standard rate cutoff point, which we were told is 40,000 euros. Then we've got to add 40% of whatever is left over. So we've got to get 40% of 10,000. She earns 40,000 plus another 10,000 to bring her up to 50,000 euros. And then we've got to subtract tax credits, which are 3,550 euros. So that's her net tax. So let's work all of those out. 20% or 1/5 of 40,000 is 8,000 euros. 40% of 10,000 is 4,000 euros. And then we've got to subtract 3,550 euros. So when you do that, you get 8,450 euros. So that's her net tax, and is that what they asked? Find how much annual income tax she pays. So that's it, 8,450 euros. Okay, let's have a look at the next one. The two income tax rates in Ireland in 2023 are given again in the table below. So up to 40,000 you pay 20%, anything over 40,000 you need to pay 40% tax. So the personal tax credits for an employee in Ireland in 2023 is 3,550. Find the greatest amount of income an employee can earn before paying any income tax. The lowest income tax rate is 20%. Okay, so what we're going to do here is we're going to let X equal the person's income. Now the person is not going to be paying 40% tax, not going to be earning more than the 40,000 euros here. So what we've got to do is look at 20% of some number X. We've got to subtract tax credits, 3,550, and we want that to be 0. So this is the net tax that this person is going to be paying, and the net tax that this person is going to be paying is 0. So 20% of their income minus the tax credits should give us 0. So we've just got to work out what X is here. So we're going to take 20%, which is 20 over 100. X of just means multiply. We're going to subtract 350. I'm going to bring that over to the other side. So it's 3,550. I'm going to add 3,550 to both sides. Next thing I'm going to do is I'm going to multiply by 100, because we've got 100 on the bottom of the fraction here. 100 is divided into 20x, so I'm going to multiply. I'm going to do the opposite. So I'm going to take 20x is equal to 3550 multiplied by 100, add a couple of zeros there. Next thing I'm going to do is the 20 is multiplied by the x, so I'm going to divide both sides by 20. And what I get is 17,750 euros. Now you can check that if you want. You don't have to do this in the exam, but let's check it anyway. This is what we're saying is this is the greatest amount of income that someone can get so that they don't pay any income tax. So let's see, if someone earns this amount here, they're earning under 40,000, so they only have to pay 20% tax. So if we get 20% of 17,750, what we'll end up with is 3,550 euros. If we subtract the tax credits from that, so we take 3,550, so this here would be the gross amount of tax that this person has to pay. Now what we've got to do is take away the tax credits. Well, the tax credits were 3,550, so that means this person will pay 0 euros in tax. So this is correct. Okay, let's move on then to part 4. In 2024, the amount of income being taxed at 20% rate was increased from 40,000 to 42,000 euros. Work out how much less income tax a person earning more than 42,000 euros would pay in 2024 compared to 2023. Well, the difference in the standard rate cutoff point is 2,000 euros. So the difference is 2,000 euros. Originally, when the standard rate cutoff point was 40,000 euros, that person would be paying 40% tax on that 2,000 euros. So when you do that, you get 800 euros. But now that 2,000 euros is within the standard rate cutoff point, so the person now is only paying 20% on that particular 2,000 euros. So that's 400 euros. So you just take 800 minus the 400 and you get 400 euros. So they will pay 400 euros less tax at the new standard rate cutoff point. Okay, so let's have a look at part C. An employee who works from home may qualify for tax relief on their electricity and broadband bills. The amount of tax relief such an employee can claim A is calculated using the formula A is equal to the total annual electricity and broadband bills times D over 365 times 0.3, where D is the number of days worked from home. Anne's annual electricity bill was 1,950 euros and broadband bill was 400 euros. She worked from home for 120 days in the year. Find out how much tax relief she can claim. Give your answer correct to the nearest cent. So really all we've got to do is put these values into our formula. So A is going to be equal to the total electricity bill, which is 1950, plus the total broadband bill, which was 400 euros. And then we've got to multiply that by D, which was 120 days, divide that by 365 and multiply our answer by 0.3. So again, just do what's in the bracket first and multiply by 120 over 365, multiply by 0.3, and you should get 231.78 euros. That's how much tax relief she can claim. Okay, part 2. Tara also worked from home for a number of days. Tara's total electricity and broadband bills were 2,250 euros. She claimed tax relief of 135 euros for working from home. Calculate how many days she worked from home. So this is just a case of working backwards. So the 135 euros goes on the left this time. Her total broadband and electricity bills came to 2,250. We got to multiply that by D over 365 and we got to multiply our answer by 0.3. So let's just divide across by 2,250 and divide across by 0.3. So I'm going to take 135. Because the 2,250 is multiplied, because the 0.3 is multiplied, I'm going to divide. So it's 2250 multiplied by 0.3. That's equal to D over 365. Okay, so what we've got to do next then is multiply across by 365. Because the 365 is divided into D, we've got to multiply. So it's 135 multiplied by 365 divided by 2250 multiplied by 0.3. Finally, that'll give us a D of 73 days. So Tara worked for 73 days at home. Okay, so that's it for this question and this paper.